Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. Sorry, I'm not quite done setting up. I thought I would be by now, but I'm actually just slightly behind. I think, good, okay. Kodo, Amaras, thank you guys so much for coming in. Studied world religions a couple years back. The name became too hard for some people to pronounce, so I switched over most accounts to Anu. Wait, have I seen your Anu account? My only exposition to the name was through Naruto. At least that means you can pronounce it. Actually, I don't know Kodo Amutsukami from Naruto. Should I know that? I feel like maybe I should know that. I did watch all of Naruto, so I feel like I should know it. But I feel like I don't, because I don't know. I don't remember where it's from. So if I Google it, I'll find something. Amatsukami. Koto Matsukami. Right. Oh, there's a Naruto one. This is... Oh, okay, interesting. Nice. Yeah, I hadn't heard, I should have known about it, but I guess I didn't. And I have some friends who are like really, really big Naruto fans, so I'm pretty sure they're going to be like... I don't know, kind of mad at me for not knowing that. Shippuden Shisui's Mangekyo Sharingan ability. Hey Gathros, how are you? It's been a long time, Gathros. I hope you've been okay. Yeah, I'm sorry, I'm not streaming in time zones that actually work for a lot of people in Europe. I understand that. That's why on the weekends I am trying to do a stream slightly earlier so I can get those European time zones again. But yeah, I hope you're doing super well, Gathros. Let's CD into projects. Simuleos, and I'm going to go into Fractal. Here we are. And let's go over here. And, CD Projects, Simuleos, my gosh. CD Projects, Simuleos, and Fractal. Okay, so today we are working on, well, precisely what the title says, which should be Chaos Games and Fractals. Gathros, thank you so much for the 24... Man, I need to do something for you guys. Like, something really cool, but I don't know what to do. So I'm just going to put 24 Simulecows in the chat, and that's what I'm going to do. 2, 3, 4, 5... Oh, no. That's not going to work, is it? 2, 3, 4, 5, 6, 7, 8... think that's 24. Okay. Dude, seriously, it's amazing. Thank you so much for all the support. I genuinely appreciate it. Also, been using your library a lot recently. I don't know if you saw, but we made quite a few animations recently. Like, for example, let's see the back directory, ls cd into computus, ls, and we should have a Gauss visualization. And if I run this video, we should have a visualization we used for computus just recently. So that is 24. Thanks, Amaris, for counting for me. Guys, I'm super tired today. I don't know why I'm just tired today. It's one of those days. Had to count them. I mean, just on my screen, yeah, it's 5 by 4 with an extra 4. So that's correct. Let's see. I'm gonna run MPV, temp video.mp4. Yeah, so it's just we made some simple animations. I mean, it's just, you know, the sun, the earth, and the moon, and we're just showing that there is an offset between a full lunar year and a full solar year. So it just stuff like that. We've been using it a lot recently. I'm using it right now for the visualization that we'll be working on today. I'm actually really happy with it. I really definitely appreciate all of the effort you put in. And I know I didn't say that before, or maybe I did say that before, but I haven't said it enough. I really do appreciate it. It's been like fantastically useful. I've been busy with master's thesis. How's the master's thesis going, man? Also, I think Folster was in a similar boat. But yeah, I remember as of a few months ago, you were looking into some knot theory stuff, but I didn't remember if that was for the. I didn't remember if that was for the thesis itself, or if that was just something on the side. But yeah, feel free to talk about it in chat. I'm more than interested. Let's go back a directory, let's get into Fractal. Right, so right now we have a simple fractal animation, which I think will just be under MPV video .mp4. So we just have this guy. Again, it's a super straightforward animation, just of a chaos game, creating Sierpinski triangle. I'm going to talk about the visualization we want to do today, why we want to do it, and all of that kind of stuff right now. So let's go ahead and go. Let's go ahead and run Zernal PP. And move this over there, and that over there. Okay, so what are we working on today? So as you saw just a second ago, we are working on an animation for Sierpinski's triangle. Okay. In particular, we're interested in a method of generating these guys called the iterative function system, or IFS. I guess I could write this a different way. Different color green too. I don't know. Iterated function system. So you might ask, how does this work? Thanks for the good question, guys. So if we have 3 points in space, this is just an example, which we'll call A, B, and C. And then we define 3 systems, F1, F2, and F3. Sorry, 3 functions, F1, F2, and F3. Where F1 is just going to be some point plus A over 2, effectively the midpoint of the point that you put in A. P plus B over 2, and then P plus C over 2 will be the other 2 functions. These 3 things together create a create a set of functions known as the Hutchinson operator, notated as H. So the idea is, if we traverse through function space, that is to say, we apply these functions to a bunch of points, whether those points be initially decided at random, and we iterate through them, or through a number of different ways, we can effectively generate a Sierpinski triangle. Again, that's just the triangle that we saw before, where it's a triangle inside of a triangle, inside of a triangle, inside of a triangle, so on and so forth. So this will eventually create the Sierpinski triangle. Now, this Sierpinski triangle is known as the attractor for this function system. And what I want to do today is I want to work on a visualization where essentially we start at point A. Well, we've already started on the visualization. We start at point A, and then we follow all possible children of point A. That is to say, it will have 3 kids, one following function 1, so it stays put, another following function 2, so it moves here, and another following function 3, so it moves here, right? And then we follow all 3 of those children, so, we get 3 kids that move in 3 different ways, and those 3 kids get 3 kids that move in 3 different ways, and so on and so forth. And that's the visualization I'm making today. We already showed that we can generate Sierpinski's triangle in this way. Now we just have to do the actual animation, which is easy and hard at the same time. We put a bunch of magic numbers into the original simulation, so we're going to have to get rid of those magic numbers and stuff. I did a project in knot theory last year. I wanted to continue it in my master's year, but I changed it in September to Riemannian geometry, and I am so happy I did. I've learned so much and enjoyed it a lot. Dude, I'm happy. My project specifically is to prove the Bonnet-Myers theorem. If a complete connected manifold has a Ricci tensor that has a lower bound that is positive, then it is compact and has a maximal diameter. Huh. Right. This is well beyond what I know, right? Like, I don't even know what a Ricci tensor is, but apparently Amaris is super excited by it. So it must be a very, maybe not common, but very interesting piece of mathematics. Yeah, feel free to keep rambling. I'm more than interested to hear more. Because the weekend streams are now at a different time than my normal time, it is usually these streams are a bit more relaxed than the other streams. So, I mean, more than likely, I'll catch everything that you say this time. Is using the Einstein field equation. Right, I know. Oh, it's used in the Einstein field equation. I feel like I should really know that. And I did cover it in quantum field theory. But I don't know much more about it. I heard about tensors. I don't understand them. This might be above my pay grade. Let's see, what do we have here? Paste that there. Myers theorem, also known as the Bonnet-Myers theorem, is a classical theory in Riemannian geometry. The strong form was proven by Summer Byron Myers. The theorem states that if Ricci curvature, I meant to click this up in a new tab, of an n-dimensional complete Riemannian manifold M is bounded by n-1 k, n-1 times k greater than 0, this diameter is at most pi over square root of k. So what you're trying to do is prove this. I don't even know how to go about doing that. I'm so bad at proofs. I don't know. The Ricci tensor describes the change of volume when moving through a space. Oh, right, okay. That's relatively straightforward. Let's see. Represents the amount by which a volume of narrow canonical of a narrow conical piece of small geodesic ball in a curved Riemannian manifold deviates from that of the standard ball in Euclidean space. Interesting. Okay. Right, so if you've got some sort of weird space-time curvature, okay, I see how this could be useful in a number of different, like, physical applications, you know, whenever you're dealing with, you know, space-time and stuff like that. Cool, man. Like, I'm super happy that you're doing something that you like to do. And yeah, I hope that continues in the future, you know? Let's see, what was I going to do? I'm going to open up Sierpinski.cpp. And we're going to move down to the visualization we need to do today, which is going to be the Hutchinson visualization, which I think, right, it's already up here. So I think what I'm going to do is I'm going to open up, how am I going to do this? I'm going to open up another terminal, stick it behind my face like I always do. Move this, let's see. I've got to make it slightly smaller, and I'm just bad at clicking. Okay, great. So now we're going to, MPV. What am I looking for here? Temp video.mp4. Oh, that was not the video I wanted. So let's go ahead and run Sierpinski. Grab a new video. Probably wouldn't have those C outs in the new video. And then we'll just take a look at that when it's done. So as of right now, we have the ability to generate a Sierpinski triangle in this fashion. So here's our Sierpinski triangle. Let me just have this on loop, I guess. Oh, well, let's type something correctly for once. So here's that right here. We have this video. Again, there's no animation to it right now. All we have is the location of all of the points. So what I need to do now is I need to move all the points such that the children move accordingly, right? So basically we start with point A, and then it sends its children off, and point B sends its children off, so on and so forth. So there's a number of things that we have to do. One, we have to remove all the magic numbers, because right now this is set on our just 720 by 1080, whatever the resolution is that I set for this. We also have to finish the animation, and we also have to do this for a square distribution. So I'm going to try to hit 1 and 2 today. That's what I'm going to try to hit. What do we have here? Topology is not my cup of tea. Well, it's a super cool cup of tea for those who drink it, but it's also... It is complicated, like super complicated. In physics, it shows that if the universe is closed, equivalent to a sphere, then the universe will collapse. Huh. So are we... Okay, as someone who should know physics but doesn't, are we on a sphere? Like some sort of, I guess, hypersphere in space-time, I guess? I don't really know. As usual, Twitch notifications are slow. Oh, are they? Did you... One second. I'm not getting a notification over here. So, if you sent something or you did something, let me know, and I will, I'll just, you know, pretend like I got the notification. Oh, I use an RSS feed. Oh, I see. Notifications that I'm going live. I see. Algebraic topology is hard, and I have lectures on that. Notifications that people go live, hence that I'm late here. Oh, I see. I totally misunderstood that. So I actually have started posting both on Twitter, and of course I still post on Discord every time I go live. Unfortunately, right now Speckled Lemon is also live. I don't usually like streaming over other people's stream time, but it is what it is. We have no idea what the curvature of the universe is. It's an open question in physics if the universe is closed or open or flat. Oh, okay. So... At least it wasn't that stupid of a question. Like, it's one of those things that I feel like I really should know. Because, you know, whenever people see that I have a PhD, specifically a PhD in some sort of physical area, they always ask me questions about, like, string theory and stuff like this. And that's just not my area. I don't know anything about it, you know? Cool. Yeah, keep chatting in the chat, and I'll catch up in a bit. Right now, I'm just going to go ahead and see if we can get this animation done. So what am I actually going to do with my life? That's a very good question. I think what I'm going to do is I'm going to modify the Hutchinson operator animation to read in a set number of frames. Actually, what does this? What's the 100 in there? What's the 20,000? What are we reading in to this function? Sierpinski Hutchinson up, and we're reading camera world int n and then bin size. What am I even using int n for? Is n even in this function? Oh boy, that's me just being bad at programming, isn't it? Here's n. Oh, there's too many n's. I don't think we're using n. So I think if we just remove these two function arguments, we'll be totally fine. So let's go ahead and dt here, g, And let's see. DT there. And move over here. I have to run the last G++. Oh no. And perfect. Okay. Linked, thank you so much for the subscription for 9 months. Really appreciate it. 9 single cows in the chat. Gather's beat me to it. How have you been, man? I guess I have to do that 9 times. I should still have this. Okay, it's fine. It's fine. It's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I need to do some stuff for my subscribers. I haven't done that in a while, but I definitely need to do it. Really appreciate it. How have you been, man? I hope you've been having a wonderful time. I keep saying I hope everyone's having a wonderful time. Admittedly, I realize we're in kind of a crisis worldwide, and, potentially some people aren't having a great time. But that doesn't change my hope that you are having a great time. You know what I mean? Let's see. I studied pure mathematics, and I didn't get an option for algebraic topology. Amherst does pure math, but I'm going to do it to a more applied field next year, cryptography. Oh, cryptography is super cool. Home office is cool. Honestly, I agree with that statement. And I agree. Let's see. How do I put this? Personally, I agree. I kind of like working from home. Admittedly, I did drive down to Alabama instead of staying in Boston, just because my neighbors are super loud, and I just couldn't deal with it. So, did I call it end frame or end frames? I think end frame makes more sense. What did I put down, though? End frames, plural. I guess if we changed it to total frames, that was tittle. Oh, boy. We'll do total frames, plural. Let's see. A bother has a box that's connected to channel points. Oh, super cool. Let's see. We'll change this to total frames. Let me take a look at this. Okay. Let's see. What?
We took a fart edition of the sound machine and took it apart, reverse engineered a little bit of it.
Oh boy.
LEDs to each of the buttons, and used an ESP8266.
He's such a great streamer. I genuinely enjoy his content. Okay. And finally, my university started to digitalize the course, so I can take course in blockchain this semester. Super cool. Hope you've been doing better since the move out. To be fair, I'm only in Alabama for as long as COVID is a thing. Whenever it stops being a thing, I move back up to Boston. So for the past few weeks, since I've been here, I've been having a genuinely wonderful time in the US. I've really enjoyed it. And don't get me wrong, like, my job is great. I genuinely love the work that I do there. It's just, living next to people who are stupidly loud at 2 o'clock in the morning is not something I particularly like. And I'm trying to figure out how to fix that situation now, but I'm not sure exactly how to do that. So it kind of all depends on, like, where my girlfriend goes and all this kind of stuff. So there's a lot of work there to be done. 1 second, I have to check something for work. I just got a notification. Also. Okay. Nice. Okay, cool. So a bill just succeeded for work, so I don't have to really touch that or anything. If I did have to touch it, I'd have to do it here on stream, because, where did you move to? Oh, so, okay. Just for the record, to be clear, I still work at MIT. I still work for MIT, right? It's just that since everything is being done remotely, I decided, after being quarantined for 2 weeks in Boston and knowing that I didn't have the virus, I would then drive again in a quarantine location in the car to my parents' house in Alabama. So I'm now in Alabama for the next few weeks. I don't know how long I'll be in Alabama, but we'll see. Okay, so now what I'm going to do is I'm going to run G++ one more time. This should run nice. Okay, so all I did was add another argument, function argument, total frames. Okay, so what I'm going to do now is I'm going to go through and we're just going to animate the creation of all the kids. That's what we're going to do. I had the choice of 4 between algebraic topology, differential geometry, algebraic geometry, partial differential equations, stats, generalized function theory, coding theory, and one other I didn't take. Right. I had all but algebraic topology. So you're talking about for your classes this semester, right? So my sister is currently doing a math PhD, and she's doing. I mean, she teaches a lot of these courses and stuff like that. She's way better at this kind of stuff than I am. I need to learn a lot more. I want to learn a lot more, but my hands are tied, with all my GPU programming and stuff. That's kind of what I do now, which is fine. I think it's great. But sometimes you just want to sit back and learn some algorithms or learn some sort of math. I have a lot of fun doing that. And I haven't really had time for that since I've come back to the US. But I guess that's the nature of being a postdoc instead of a PhD student, right? As a postdoc, you're actually expected to get work done, whereas a PhD student, there's some expectation that you'll be spending a lot of your time learning instead of getting actual research done. I guess it depends on who your boss is as well. Okay, so what is this doing? So this is kind of a complicated mess of code. I'm going to go ahead and comment this and say this is creating all the children. And I guess we're just going through. I guess we're going through child by child. So, what do I actually want to do here? I had all but algebraic topology. Let's see. Bono-Kazooie, sorry to interrupt, but what subject is your doctoral thesis in? It is in, I guess you could say computational physics. So, the thesis is actually online on GitHub if you want to take a look. github.com/leios/thesis should be here. Yeah, so feel free to take a look. The actual title, I misspelled GitHub. That should work. Right. So the actual title was Massively Parallel Split-Step Fourier Techniques for Simulating Quantum Systems on Graphics Processing Units. And here should be the final version. Might take a second to load. Here it is. Massively Parallel Split-Step Fourier Techniques for Simulating Quantum Systems on Graphics Processing Units. So this is the thesis if you want to take a look. Let's see. I see it in your... Oh, dude, is it in my info? Cool. I think coding training is really cool, especially if you like algorithms. Coding training is amazing. Like, honestly, Dan is like one of the coolest coolest people I've met in general. We had this YouTuber conference a while back, and we're going to be having another one as soon as COVID is over, where we just got to meet all of the educational content creators. And man, they're so cool, right? If ever you want to be motivated to make content online, just go to that group. Like, honestly, they're amazing. Bono-Kazooie, thank you so much for following. Really appreciate it. Okay. So this is creating all the children. That was a stupid comment, but maybe I need it. So I guess what we're going to do is we're going to create some sort of set of frames. So when is A done drawing? So we have A, B, and C. So let's see, we have a triangle, add animator, 0 plus I times 10, and then 30 plus I times 10, and I goes to... Okay, so what I'm going to look for here is I'm going to start with an offset of 100. So let's just say... Oh, I don't know what to do here. I guess we're going to call it draw frame. Something like this. And we're going to say it's going to be equal to 100. Well, let's do 120 because we're at 60 frames per second. We'll say int here. Okay, so this will be the frame that we're initially starting to draw from. So the idea is we've generated A, B, and C. And then after generating A, B, and C, we'll start drawing about a second after they're generated. And then we'll start just throwing the children out, right? And that's what we're going to do. Let's see. He said coding theory, not coding. Oh, no. I'm so sorry. I totally misread that. I'm sorry, Amaris. My bad. That's what I get for just skimming the chat instead of reading it thoroughly. You should see me on research papers. But you said coding theory is really cool, especially if you like algorithms. The problem is it could work for both of them. And actually, I did enjoy my coding theory class. It was a good class. Okay, so we have the ability to generate our point, an STD make shared. So now all I have to do is add an animation to that point. So we're going to say point dot add. No, that's correct. Pointing to add animator. Misspelled it. Something like that. vec animator. And what we're going to do is we're going to change its location, I think, is what we want to do. Yep, I think that's what we want to do for now. We'll see how this goes. The color, actually, so this is going to be from frames, draw frame. Wow, pretend I can type. So draw frame. And then it goes to draw frame plus, we'll do 30 for 30 frames. And all we're going to do is we're going to say point, let's see, 1 second, point, I guess pointing to location. I think it's just loc. And we're going to give it its initial location and its final location. So let's see, where, ooh, we have to figure out its initial location, which means we have to find its location. For now, just to make sure this is working, I'm just going to put in the location of one of the initial points. So I'm going to put in the location of triangle points, PTS, of I. Again, this is just to make sure it works, and then we'll go and make it more complicated later. And then we'll have to do, oh no. Point is going to be make sure, it should just go to location. That should be correct. Something like that should work. So I guess here we're going to say, instead of location, this is going to be triangle PTS of I. Pop this down to the next line because I feel like it. Okay, write that. Does this compile? It's going to be a miracle if it does. It does not. It's because this probably needs to be location. There we go. Okay, so we're going to do /Sierpinski, and we're just going to see what this does. Why am I see-outing anything? How do I stop see-outing? See-out. Ooh, this is going to be really dumb. Oh, this is going to be a really dumb visualization. Hey, Fulster, how are you? Let's see. I hope you guys are all having a wonderful day. And let's see what this visualization looks like. What? Ah, there it is. Control C. There we go. Wonderful. Okay. Is this... Yeah, that's the animation. Right. Yeah, there's nothing. Oh, well. I'll try to figure this out then. I would have suspected A, B, and C to be generated at least. What did I do wrong? Well, let me see. So we have draw frame. We have draw frame there. Draw frame there. I'm going to do more fractal flame coding today. Dude, enjoy your time. I mean, you have some really, really cool fractal flames already, and I'm sure you'll have a bunch more by the time we have fractal flame in the algorithm archive, which is totally happening. Hi. You okay there? C252? Like, is everything okay? What's all the S's? Oh, that's something on Twitch. Okay, I got it. I'm so sorry about it. Why is it all S's? Is that like a Minecraft meme that I should... I'm sorry. Probably a Minecraft meme I should know. Let me comment out the animator. Make sure everything still works without it. Maybe it doesn't. Who knows? G++ /Sierpinski. Okay. Let's see what this looks like. Okay. Give it a second. One thing to note, we are generating a lot of kids. Oh, it doesn't work. Okay. Well, that's good to know. I broke something actually important. Let's just do a git diff to Sierpinski.cpp and see what we got here. We have int n, int total frames. I don't think n, that should be fine. Int draw frame is 120. Point is SD, make sure ellipse. This should still be fine. For int I is less than 100. Well, let's just comment out this entire block. Just because that's something we can do. Paste here. DD and let's see. Paste here. That should work. Right. So let's queue here and run g++ /Sierpinski. I don't know how I broke it entirely. He goes and then explodes. Oh, interesting. I've maybe discovered the worst form of version control in the world. What is this like? updated on some Excel spreadsheet or something? Okay, so there are 3 points. Cool. And why, when we put this back in, do those 3 points not generate anymore? It's probably some stupid pointer thing that I'm not taking into account. Let's see. Whenever I generate a picture with my code, I'm injecting the code that generated it into the binary of the image. Oh no. So I can unzip the image to get the code that makes it. I'm writing a graph coloring algorithm that I made some visualization for. It has accelerated my research. Cool, man. Man, I want to do graph coloring. Man, there's so many things I want to do. Like, this is a problem. I have too many things I want to do, and I do none of them because I am what you might call bad. Let's see. For the record, I do think that's a pretty bad form of version control, but at least you're using version control. Well, no, you're not, are you? How's that version control? It's hardly... Yeah. MPV? Right, so now all the points are dumb. Why? What am I doing to make all the points dumb? I thought it would have to do with this add animator, but we commented this out, and it was still stupid. But I thought the only thing we changed was that. So maybe we change this back to location? Huh. G++, /Sierpinski. Let's see what this does. JB55, hello, how are you? Thank you so much for the 13 months. Man, it's been 13 months? What? Okay, thank you so much. Simule Cow in the chat. 13 of them. Let's go. Right. So I did miss last weekend's stream. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Bam. Thank you so much for the following. Thank you so much for the follow. There we go. That's what I'm... Subscription. I'm just can't speak today. Thank you so much for all the support. I really appreciate it. One thing I want to point out is that I am going to be trying to do kind of slightly earlier streams. So for those of you who are in Europe, I'm going to be doing streams that are kind of off my evening times. So, okay, here's the problem. Moved to the US, my stream time changed to like 6 p.m. to 8 p.m. or something like this. That works for me, but it doesn't work for people in Europe. So for people in Europe, what's the best time for you guys? Should I do like maybe... I don't even know how to describe this time to you, but is now, whatever time it is now, minus maybe an hour. We'll say 2 hours. Is that okay? New emote idea? We have a lot of emotes. It's around 11 to 10 here. Right. So, yeah, if I started at, let's see. So right now it is about 4 o'clock in the afternoon, Alabama time, I think. It is, yes, about 4 o'clock in the afternoon, Alabama time. So if I started at, let's say 2 o'clock in the afternoon, would that be, okay, so 2 hours before now. That's the time I'm kind of thinking of. Did that just finish? Okay, well, there's our triangle, at least. Kramer43, thank you so much for following. Really appreciate it. We have a lot of emotes. We have 2 emotes. I know, I need more emotes. We had a lot of emote ideas, and none of them came to fruition. How about tomorrow we just do an emote stream? That's what we do. I know this sounds really dumb, but I can make like 5 emotes right now. So we'll just do a stream where we're just thinking about emotes to make, and that's it. That's a really dumb stream to do, but it's something that I feel like needs to be done. We might not do it on stream. I don't know. What do you guys think? 10 p.m. now. That's not bad. We have a lot of emotes. We have 2 emotes. It's a fantastic time. 3 to 4 your time sounds good. Okay, cool. So I'll try... and also I want to do slightly longer streams on weekends as well, because, I mean, I have time for it kind of on weekends. I pretend to have time for it on weekends. So, you know, in principle, I should be able to do more. Okay, so... what happens if we... I don't understand what I need to do here. Mr. Umel, thank you so much for following. Really appreciate it. Okay, so what are we going to do here? We have some location, and I guess we want the location of the parent as well. So what I'm going to do is... what am I going to do? We have the value string, which is going to be save trite here. Oh boy, how does that work? So we're incrementing up. And what I want to do, how do I grab a substring? So we'll say parent location is going to be equal to apply trite of, we'll say parent string. I don't know, something like this. And then we'll do triangle points of j. Oh, that's why. I did triangle points of I. Aha. Figured out the problem. But that doesn't really help in any way, shape, or form. And we'll do triangle points. Okay, so for those of you who may have missed the previous streams, the way I'm actually generating all these children is like so. So we started at some point A, right? This point A generates 3 kids, 1, 2, 3. And all 3 of those guys generate 3 more kids, right? In our case, because I didn't want to have the whole tree in memory, what I decided to do is I decided to basically read this out as if it were like a Huffman tree or something like that. So the idea is if we go down the left, we'd use function 1. If we go down the middle, we use function 2. If we go down the right, we use function 3. So 1, 2, 3. So if we want to read, let's say we want to get to this child in here, well, that's just taking A and applying function 1 and then applying function 2 to the output, right? Oop. Something like that. So in this way, we can basically go through all of the children in our simulation simply by counting up some sort of trit string, right? So the idea here is that we have like, if we have 1, 2, 1, 1, 2, this is our trit string. But essentially all this means is that we're using function 1, function 2, function 1, function 1, function 2, all on A, or some initial point, right? So function 1, 2, 1, 1, 2 will be all the functions necessary for the child. That spells child. But function 1, 2, 1, 1 will be for the parent. So what I need to do is I need to find a substring that's basically the exact same trit string that we have before, but minus this last element. I think that's what I need to do. Let's see. Hey, Fract Chemist, how are you? If you guys don't know, definitely check out Fract Chemist's channel. She has really, really cool content. She's been doing a lot of IRL streams recently, but she talks about science all the time. It's a wonderful channel. Definitely check it out. I love fractals. Fractals. Oh boy. I don't understand it with computers. I don't think you can make fractals without computers. That depends on your definition of fractal, right? Like if you define fractal to be anything in a non-integer dimensional Hausdorff, you know what I'm saying? If you have a Hausdorff dimension of non-integer size, and that's how you define a fractal, then in principle you can find fractals in real life. But most of the time when people say, self-similar fractals, that's something that you can only generate with, that's something you can generate much easier on a computer. Sean and Whittle? No, Sean Dinwiddle. Thank you so much for following. Really appreciate it. Witty. I'm sorry, I'm really bad at names. I know it's in the context of polymer chemistry, which are self-similar. Oh, actually, that's really cool. I can make the dragon curve. I should know the dragon curve, but I don't because I'm bad. Okay, so let's see. How do we get the parent's location? So we need to find a substring. So we're going to say parent string is going to be equal to, should it be value string? Underscore string. Dot, oh my gosh, string dot substr, I believe. And then what we're looking for is it value underscore string dot begin to value underscore string dot end -1? Is that what I'm looking for? Let's pretend I remember substrings from C++. I know I don't, but let's pretend I do. Oh no, get status with 200 lines? Right, so there's many different things that you can do in that case. The easiest thing to do is just to give up. Oh, I didn't know about get status short. Dude, thanks, man. Substring, let's see if this actually works. I know there's like a dot begin and dot end, so I'm just going to assume this works. Let's just compile it. it compiled. Okay, so let's just keep going. So we'll have parent location. I didn't define what a parent location was. So where did I define where location was? Loc. Oh, loc. So we'll do parent location. I should just have a resize function as well, but I don't, and I don't care. So we'll do yank to yank, paste in here, and we'll say parent location. Forgive me, guys. I know this is super messy code. We can clean it up in just a bit. That's the next step after getting it working. Okay, so it should start at the parent's location. And then it should move from the parent's location to the new location. Okay, let's just see what happens if we try to compile that and we run an animation. Yep. I should have expected that. Like I don't know why I expected anything different, honestly. Is this right? No. No, clearly whatever I was trying to do is just dumb. Right. It's beautiful code. It looks like the Matrix, I think. I've never seen it. I've also never seen the Matrix. I hear it's cool. A fractal is a shape whose Hausdorff dimension is strictly more than its topological dimension. I don't really understand what the topological dimension is exactly. The topological dimension should be like the dimension, like 2D would be a square or something like that. Oh, Soding, hey, how are you? Thank you so much for the raid. 205 people. I hope you guys were really enjoying Soding's channel. If you guys were on my channel before and you don't know who Soding is, he's a wonderful programming streamer. He is usually live, I guess, around this time, right? And he just does some really cool stuff. If you saw the viral Reddit post, I think ping pong and stuff like that, that was by Soding. He did a lot of really, really cool stuff. Definitely check him out if you can. Let's see, who do we have here? Nulligator, Blexack, and Gregory Alex. Thank you guys so much for following. Really appreciate it. But yeah, I hope you guys had a great stream. I wasn't able to check it out before streaming, so what were you guys up to? Feel free to talk about it in chat, and I'll catch up, and we'll go from there. Wholesale Failure, thanks so much for following. Really appreciate it. So, for those of you who may not have seen this stream before, we are talking about stuff. In particular, I am Dr. James Schloss. I recently finished my PhD found here, and I'm now working at MIT on a project known as klima.caltech.edu. It's a climate simulation. What we work on here on stream is actually a side project known as the Arcane Algorithm Archive, where we just talk about algorithms. That's the whole thing. Our most recent algorithm was Computus, the Easter algorithm. It was an algorithm to compute the date of Easter. We just talk about algorithms. That's our whole thing. So what we're doing today is we are talking specifically about the generation of fractals and fractal-like systems via iterated function systems. And so, one such system would be one that you can find. Let's just go ahead and play it really quick for you guys. Let's do, what am I looking for here? Probably projects, Simuleos, fractal, and then we'll do video.mp4. There we go. Okay, so just like Sierpinski's triangle and stuff like that. I'll talk about the visualization we're exactly working on in just a second, but this is kind of the main crux of the video. We're just generating these fractal-like structures with a known algorithm. Let's see, what do we have here? Let's see, Wholesale Failure, NGT07, iPave, Nia Insomnia, Mortalol, and Ezra Flag, thank you guys so much for following. Really appreciate it. Let me catch up on chat, and then I'll talk more about what we're doing here. Your follow gifts, thanks, Fret Chemist. Really appreciate that. We're learning quaternions. Oh boy, that sounds super fun, man. Learning quaternions in Rust. Oh wait, were you? Okay, so I know 3 Blue 1 Brown, and who was it? It was. Oh gosh, I have his business card. He's an amazing guy. He does like GPU. Oh gosh. He made a GPU on a circuit board. What is the guy that I'm thinking of? Ben Eater. There we go. Not Ben Easter. Ben Eater. Right. They made like an interactive demo for understanding quaternions that was super cool. I don't know. Maybe you may have looked at it before. But yeah, doing it in Rust is a whole nother situation. Let's see. We were looking at nutations after quaternions. You got free advertisement from Simuleos. I'm sorry, we didn't have too many people here before that. But I'm hoping that, some people come on. I heard a lot about them, but never tried them. So today was the day. Oh boy, it's hard, right? Because you have to think in like kind of 4D space. It's not easy. It's a coded animation. Let's see, 3.40282737 e to the 38 nutations at a complete invariance factor of 0 for basic quaternions. Cool. That was really recent. I think the last stream I saw of yours, you were prepping your defense. Right, that was a few months ago. But yeah, thanks so much. I hope that your stuff's going well as well. Let's see. Arch, by the way. Yeah, I use Arch, by the way. I like Arch. I'm sorry, I'm a big fan. Watch that. It was something. His name is Ben Easter because he invented Easter. Right, totally did. Missed a few follows here. Let's see. Kelp Map, Crump Eater, Agthar, BB Bob, NECA 420, Petrocloss 007, Bravo 5555, 8 Infi. Thank you guys so much for following. Tim the 5th, appreciate it. Right, how's MIT coping with COVID? MIT's doing okay. Like my job hasn't really changed that much. There have been a few positions, like there is some loss of industry funding, which is hurting a bit, but it's not. So far, the research is still going on for my stuff because I do mainly computational stuff. I know a lot of people are struggling with it more, specifically if they're doing experimental work. They're basically put on hold for now because they can't do anything, and that sucks. Specifically for, I'm thinking about graduate students, because, the graduate students have, they have a deadline. They have to get their thesis out, Let's see. 7 Odd Failure, Magnet Colas, and Man in Black. Thank you so much for following. Really appreciate it. They have a depth line. Yeah, they also have a debt line. iPave, how old are you? I am 27. At UF, we can't do any research in lab. It's all lit search. It's so brutal. Right. I mean, especially if you're used to computational work or if you're used to experimental work, it can be very difficult to deal with. And I totally understand. Totally understand and sympathize with people who are, struggling to get anything done. I'm in the lucky position that my job didn't really change too much from day to day. I'm still doing the same simulation I was before. It's just now I'm doing it from home instead of from the office. So, Canada's harsh as what for that? I read up on scientists trying to make liquid crystal optical computing thing in 1992. Cool. Yeah, no, I'm very lucky, and I consider myself to be very lucky in a number of ways. I mean, my PhD was amazing. My first postdoc is at MIT. I mean, come on, you can't get better than that. And so I really do appreciate and understand that I'm kind of blessed to be in the situation I'm in. And yeah, as much as we do fight and bicker about, the nature of academia and whether, we should be going down this route or that route, in the end, I think I'm doing okay, and I'm happy that most people on stream are also doing okay, As me as a mathematician, I didn't need anyone. Yeah, that's fair. I don't know if that's positive or negative, but that's fair. On reflection, my Git status has 475 lines, even with the short. Sounds like something Oleg Lavernok would do. Let's see. Yeah, fundamental computational research is not really affected as much as experimental research. Right. Okay, so let's talk about the animation I'm doing right now. So just so everyone's caught up, here's what we're doing. We have this triangle to generate, right? So the way we're generating this triangle is basically by creating a set of 3 functions over here in red. Function 1, function 2, and function 3. They're over here, right? So all these guys are is you take some point, initial point, you add it to A, B, or C, and you divide by 2. The function returns the midpoint between the point you're putting in and one of the 3 positions of A, B, and C. That's all it does. So if you take a point in A, right, and you plug that into function 1, well, you're going to get a point that stays at A. If you plug it into function 2, you're going to get a point that goes over here. And if you plug it into function 3, you're going to get a point that goes over here, right? So in this way, basically, you have A generating 3 children. Now, all 3 of those children are then going to generate 3 more children, and those 3 children will generate 3 more children. And what we're trying to do is we're trying to track the motion of these children as they're moving around. Now, if you look at this, clearly, you'll have A generating 3 kids, and those will then generate 3 kids, and this blows up exponentially, right? So what we're doing in order to make this a bit more easy, well, not easy, but we'll say more memory efficient or whatever, is we're actually going to be regenerating the point every time by basically applying all of the necessary functions to A to to generate each of the children points. Now what do I mean by this? Essentially we're doing is we're saving a trit string, here 1, 2, 1, 1, 2, and in order to get to, that child that goes down function 1, function 2, function 1, function 1, function 2, we just, every time step, apply all these guys to A. In this way, we're saving a bit on memory, although using a bit of compute space. So this is kind of how we're doing it. So as of the last thing that we did, what I'm trying to do right now is I'm trying to generate the location of the parent node. So let's say the parent node is this one in blue, and also the location of the child node. So we have the location of the child node because it's just applying this string, and the location of the parent node is going to be applying this string minus the last element, right? So all I'm trying to do is create a substring, plug that in, and we should have everything ready to go for a relatively straightforward visualization. And then we just have to kind of soup it up, make it look pretty, and that's going to be the bulk of the rest of the stream. For the record, I do appreciate all of you guys, and I hope you guys are all having a wonderful day. Feel free to keep up the chat. I'm going to do my best to catch up with it as soon as I can. And yeah, this is kind of what we're working on. So the moment you guys popped in, I had a bit of a compilation error, and that's kind of what I'm working on solving right now. Let's see. Never made it to uni because I hated it. Looking them up. Let's see. Do you have to do research for it? I think it's good for experimentalists. It forces them to write and reflect. We get so obsessed with collecting data after data and doing experiment after experiment, and then wait until we have an insane pile before we reflect on it and analyze it. It's forcing us to reflect our experimental, right, on your experimental systems. Right, if that's actually what it's doing, I'm more than happy that it's happening. But it's I personally love the lit review. So, like, I love reading papers, learning new algorithms and methods. That's kind of my favorite part of research. Don't get me wrong, I also enjoy writing code every now and again, but I tend to really just prefer like just reading and writing. That's my go-to way, or my go-to method to engage with research. So I don't know. I see what you're saying in that. I mean, you just said that the lit is the awful part. I kind of see the lit as most of the research, and then, like, kind of the coding as kind of a validation of the literature review, in some ways. But it just depends on how you want to do research, right? Riemannian geometry, more specifically proving the Bonnet-Myers theorem. Let's see. Hi, Build Earth and Micron project just switched map projections to a version of Dimax. Dimaxing with the help of Daniel Strebe, a computer scientist and mathematician who specializes in map projections. Cool, man. Let's see. I thought it was super cool. And yeah, no, it's super cool. Thanks for letting us know. It's actually Bob Lemieux from the University of Waterloo. I like reading. I hate the idea that so much sat on shelves as I was junior middle school in 1993. Yeah, that's how it goes. Wondering why the world outside looks like modems on dial-up? I don't know what you mean by that. By the way, a few minutes ago, I missed a follow by forced to sign up Twitch. I'm sorry that you were forced to sign up on Twitch, but I do really appreciate the follow. Thank you so much. Hello there, greetings from Italy. I'm sorry for my English. I'm trying to be a programmer, but it's so hard because sometimes it's overwhelming. There's so much to know. I just try to know as much as I can, but every time I write code, I'm like, am I doing the right thing? Surely a good programmer would joke on that. Right, so truth is, if you're trying to learn to program, you got to be humble about it, because no doubt there's going to be some guy out there who's better at programming than you are, right? That's just how it goes, So what you need to do is you need to sit there and just write code and just keep writing code. I mean, like any other skill, you've really got to just jump into it and try it. And the more you work on it, the more you work out, the more you flex your coding skills, the better you'll be at it. And eventually you'll be at that senior developer level where you can help out newbies and stuff like that. Probably if you're just getting started with programming, you're going to write code that's going to look really ugly. But that's how any creative endeavor starts, When you start playing the piano, the first thing you play is going to be really bad, When you start learning to draw, the first things you draw are going to be really bad. Anything you do that's creative, and I consider programming to be incredibly creative, it's going to look dumb. I mean, look at my code right now. Senior programmers are going to laugh at this. But the truth is, you just got to take it in stride. When someone says your code is ugly, that doesn't mean you're ugly, right? Well, okay. I can't speak to that part, but I can say that if someone says your code is bad, that doesn't mean you are bad for writing it, right? It just means that you didn't know any better, and now you'll learn better and you'll get better, right? That's how I believe it, anyway. He got, let's see, optical switching pneumatic liquid crystals for, let's see. I bet most programmers have the mentality of make it work. That's probably true. I wonder why copper wire was so monopolistic. I had to pull the mafia down on that. Was it being humble is key? I wrote some truly awful SQL queries yesterday. I so wish that this was true in academia. I'm so bad at writing applications because I can't brag very well. Yeah, there's an art to bragging in academia, right? Like, I don't know. I sense __ insanity 9619. Thank you guys so much for following. Really appreciate it. Let's see. You walk back on that doesn't mean you're ugly. I'm sorry. It didn't mean to be personal. I'm sorry. I wasn't saying that you guys were ugly. I'm just saying I haven't seen you, and let's move on. Software development. Make it correct, make it clear, make it fast. Yep, that's how I believe it to be anyway. That one was really inspiring. I hope so. I started work at a huge research center here in Germany, and our team is somewhat in between. We are kind of a support unit. We do both digging into papers and building coding, the specific tooling for scientists. Actually, I'm pretty happy with it. Being more of an engineer, but having the opportunity to learn from the scientists and peek into new and unknown topics. Right, so I reckon you're in a research software engineering role, right? I, too, am kind of leaning towards a research software engineering role as my next position, but we'll see. If you're ugly, it's not because your code is bad. That's how I should have said it. I knew what it meant. I knew he meant inspiring. Maybe he did. Inspiriting. Where are you at your code today? Well, we're at segfaults right now, but we'll get there. I promise we'll get there. I'm gonna get back to coding. I'll take a look at chat in just a bit. But I need to figure out why these segfaults are doing what they do. Parent string was not declared. That's probably because I didn't declare a parent string. So I'm just going to do parent string. Now you might be asking, why are you defining all your values before this loop? That's a good question. There isn't really an answer to that. I'm just bad at programming. Okay, so we're going to do G++. We're going to clear this a couple times. And let's see if we can get that error out and figure out what the problem is. Yeah, okay, I thought it was that begin and end statement. I'm really bad with substrings in C++. I know I just looked this up. In fact, it's right here. But I know there's a way to do like a dot begin or something like that, and dot end. I know those are things. I just don't remember the exact notation. I haven't been doing C++ in so long. I'm just super rusty at it. Let's see. It's string.substring. A.size, B.substring, A substring I2. I swear it's a thing. Oh boy. Let's see. What's the name of the algorithm website you visited before? It's right here, algorithmarchive.org. Here's the latest chapter for Computus. Cool. It's late at night here, and I feel numb already. Dude, it doesn't have to be late at night for me to feel numb. Like, I always feel numb. Oh gosh, that was super dark and depressing. I'm sorry about that. I hope everyone's having a great day. Okay, so C++ substring. Whatever your PhD thesis, what was it about? I just got this question a bit ago, and let me just go back to it. GitHub.com. It's available on GitHub. Should be here. And I'll just give you a link to the final thesis.pdf. There you go. So it's massively parallel split-step Fourier techniques for simulating quantum systems on graphics processing units. That's what it is. So feel free to take a look at it. I'm not guaranteeing you can read all of it because it's a lot of technical jargon, but I think it's relatively readable. I tried to keep it relatively readable, so I'm hoping you can read it a bit. I was super happy when they allowed me to put it open source on GitHub. I was really worried that they wouldn't. Actually, maybe this was more of a, I didn't really know, I don't know if I really asked permission for it. But I certainly did it. So, you know, dang. How do I, let me try Google. Substring C++, string.substring. We can do 3 to 5. And what do I want to do? I guess I want to do 0, 1, 2, 3. So I want to do 0 to the last number. So what if I just do, what if I, instead of doing this weird dot begin and dot end notation, which is, again, admittedly a bit funky, what if I just do this, and I do, let's do 0 to, oh, if I do 0 to, value string dot size -1 should do it, I guess. Doesn't compile. Value string dot size. Oh, right, because I need to do that. And I think I have one too many parentheses. Okay. Right. Let's clear this a couple times. Take a look at it one more time. Okay, what's the error this time? Triangle points J was not declared in the scope. Did I misspell triangle points? No way. No way I misspelled triangle points. Don't give me that. Parent location is going to be parent string, triangle points of J. I see the problem. There we go. Crap. I was so sure. I was so sure it would work. Okay, let's do it again. There we go. That worked. Let's see what the animation looks like, because I know it's wrong. And we'll just mess with it from there. If you guys have any questions about academia, programming, weird mathematical things, feel free to ask. And I'll be more than happy to respond as soon as I can. Yep, that's what I did. I went to a Japanese university, so I went to the Okinawa Institute of Science and Technology for graduate school. That's what it was. It's a wonderful place. I would definitely recommend you going there. The best plotting library for C++ is FFmpeg. Favorite libation? Shotomate. Right, so my favorite... I thought that was a word I should know, but now I'm like convinced that's not a word I should know. Look at pull request 675. Okay. GitHub.com. Algorithm archive. 1 second. 1 second. Algorithm archive. I assume pull requests. And major restructuring. Oh, whoa. Other than a bloody right, started merge building tool. Actually, oh, is this algorithm archive Python? Tell me this is algorithm archive Python. What is this? Let's see. Pip file. Oh boy. Trash talk. You are amazing. So this should be, if this is what I think it is, which I think it is, this should be the algorithm archive Python version of the algorithm archive. This is a huge bit of drama here that I have to. Okay. It's a mess, but that's okay. Let's work on this. I'm a big fan. Big fan. Let's see. What do I want to do? 480 files changed, man? Dude, thank you so much. Okay. So for those of you who don't know drama, let's talk about Git drama. So journal, new page before. When we started the algorithm archive, here notated as Arcane Algorithm Archive AAA, we started off with this thing called Gitbook. About maybe 6 months into this whole Gitbook thing, they decided that they would no longer have an open source version of Gitbook for us to use, and they would turn to a proprietary version only. They left the Gitbook tools available, but the truth is that pretty much every time we tried to use the open source tools, it would bust. I mean, not bust, but there would be issues with it, like, security issues, and GitHub would constantly be telling us that we need to update this, and it's just been a mess, And so we've been using this old version of Gitbook for a while now. And a long time ago, this guy named Nev came by and created an algorithm archive version that uses entirely Python. And for the past few months, Trash Talk has taken this over. Trash Talk, who's in the chat right now. And I think we're at the stage where it's almost done. So we're pretty close to having a version of the algorithm archive not reliant on Gitbook, which I am incredibly happy about. Let's see. Habamax and Venal, thank you so much for following. Really appreciate it. Let's see. Let me catch up on chat. Look at Polar Wisdom. Thanks, Cathros. Highbrow Comedy Act. I did some things there. Get some booze. What are your thoughts on Wolfram Physics Project? I talked about this somewhat at length yesterday. I don't know enough to really give an informed opinion, but I am very glad that people are engaging in this topic. I did some things. Trash talk. It's Algorithm Archive Pi, and it's also mess. Merge into a new branch. I'm surprised if you get it running. Is competing with JSPP for a number of changes. Gitbook is proprietary. Right, I agree. It was good software. Like you're here. Thanks, Zent. 12. Appreciate that. Something. Sorry, Trash Talk was just phrasing. Just really tickled me. I believe restructuring is spelled with without an O. Is that? That is spelled with. I can change that really quick. That's easy to change. But yeah. Okay. This is. I'm a fan. I'm gonna put some stuff on it. Oh, maybe that one's not appropriate. Let's remove that one. But let's put down... I put the same one down again. Crap. Why am I so bad at... no, not that one. Okay, screw it. I just put down those two, and I'm going to request myself a review. No, I'm going to sign myself on this one. Okay, cool. We were going to do maybe an emote stream tomorrow, since we need... Let's talk about this more tomorrow. Oh, you get notifications every time you do that? I'm sorry, I didn't realize you got notifications every time you put a like on something. I'm so sorry, Gathros. My bad. I'm going to stop. I didn't realize that. I don't get notifications. Why do you get notifications? What? I'm definitely subscribed to the same repository, but why do you get notifications? Okay, fine, fair enough. Cool. Okay, so let's get this visualization underway, and we'll do this, and then we're going to take a look at that probably tomorrow. Oh, that wasn't the right video. MPV, temp, video.mp4. Oh, well, that's a thing. Okay. Do any of them actually move, or are they just all stuck in place? Oh, I think they're all stuck in place because I see. So we have to add the animator. DD there, and we'll do draw frame from point location from the parent location to their final location. Right, that. Let's just see what happens if we run this. And then we do /Sierpinski. I have no idea what this is going to look like, but I'm hoping it looks cool. Probably it's going to look really dumb. I'm just trying to get my my work out there because it's mostly sitting idle on my laptop. It's good. I mean, we'll do some reviews of that. Thank you so much for that. I really do appreciate it. Let's see. Okay. If you guys have any comments, questions, concerns, anything like that, feel free to let me know. And I'll totally address it as soon as I see it in chat. Schnitzel, thank you so much for following. Really appreciate it. The reason this takes so long to render isn't because of FFmpeg. It's actually because of various other things that are happening at the same time. Oh, maybe this one is taking a while because of FFmpeg. Well, we'll just see what happens. I love how versatile GathVL is. It shocks me every time. Honestly, I'm a big fan. Like, yeah, there's some things that, like, syntactically are weird, but that's because of C++. Like, the shared pointer thing is a bit weird. But again, for a C++ library that does animations, it's pretty dang good. And I'm a big fan. I guess I can just say, again, thanks for making it. Right, let me get some water. I want to be more like a C graphics library. Yeah, I guess the shared pointers didn't exist in C++, right? Or didn't exist in C. This is taking a lot longer than I thought it was going to take. And I am not entirely convinced the output is going to be exactly what I want it to be. So, I hope you guys are all having a wonderful day. I think we actually want to add 2 animators to each of these guys. One for its location and the other for its size. So we'll have it... oh, okay, well here's the animation. We can at least look at it. MPV. Whoa! That was an animation. Holy crap. That's super trippy. It's not what I want, but it's super trippy. Yeah, I'm a fan. I'll just let that play and loop in the upper whatever corner. All right, let's see. Yeah, the problem is it loops, but the next it's like, well, it takes too long before the next run. So, that side of the screen is called left. Oh, did I call it right? I'm so sorry. Is there any way to draw a serpentine triangle in one pass? Yeah, you could do it in a number of different ways. But this animation isn't exactly where I want it to be. Upper whatever corner. Oh, thanks, Gibbous. You know, I'm good at language. I appreciate that. Oh, that was a wrong line. Okay, so this does mostly what I want it to do. Now let me think. How do I actually want to get this to? Okay. I guess what I'm gonna do is when I generate the point, I'm going to have it set so the point. Okay, I know what I'm gonna do. So the point's initial size is actually gonna be 0, 0. I think right now it's set to 2, 2. Is that the size? No way, that's the size. I guess that is. Let's just do 0, 0. Okay. And then when I add the animator, I'm actually going to add an additional animator. But this is going to be for the point's size. So we'll say size. And we'll just do vec 0, 0. 0, comma 0. And it'll go to vec of 2, comma 2. Okay, so this isn't going to be the final animation, but I think this will be somewhat closer to what I want it to be. So we're going to add two animators at the same time, one that grows the point, another that moves it in the appropriate direction. Are you using Arch Linux? Yes, I am. What is this? Oh, is this talking about how Arch is better than everyone else? Let's get that compiling, then I'll take a look at the clip. Control C. Okay. Oh, yep, that's the exact, that's it. That's the one. Even better than Manjaro. Manjaro is Arch, isn't it? It's the same thing. What's the name of that triangle model? Sierpinski's triangle. I would like it to be more like Raylib. I actually don't even know what Raylib is. I should probably know. HTML. Right. So shaders. Huh. I mean, in Cairo? I'd be surprised if you could do this in Cairo. The truth is, I tend to... How do I run this example? Let's see. Yeah, this seems like an OpenGL library than anything else. Zent12, how hard is it for a beginner to install with Arch Linux? So I started with Arch Linux. It was my first Linux distribution. Now, you could argue that, look at the code. I did look at the code. And you're right. I think it's relatively clean, but you still have to do, I like the simplicity of the code. Yeah, okay. I understand where you're coming from. I definitely agree with that. To the question of installing Arch Linux, again, if you haven't installed Linux before, I would argue Arch is okay, personally, I love the fact that I started with Arch. It was, the first distro that I tried. I was 14 at the time. I had never done anything with Linux before, and it hooked me. Like, doing the Arch install was the thing that hooked me on this operating system. Oh, I just messed with the music. Sorry about that. Okay, so we have the 3 points, and... Okay, so now we just have that animation, which is fine. Okay. But yeah, it genuinely did hook me. I'm a big fan. There's no music? Oh, there's definitely music. This is the thing. Let me increase that then to -30, I guess. 1 second. I don't remember what it was before. That's -25. I'm going to guess it was... Maybe -25 is fine. Maybe that's fine. Well, I mean, maybe we do... Yeah, we'll do 25. Something like that should be fine. Okay, sorry about that. I didn't realize the music doesn't matter too much, but I do think it like helps with the general stream. You know, I don't know. Okay, well that animation was close to what I wanted it to be. Cool. Okay, so now what we're gonna have to do is we're gonna do. Am I the only one not hearing? Is anyone else not hearing music? Let me know if you're not hearing music. I can increase it. I can make it bigger. Pretty sure there's actually no music. I just don't think it's coming through Pulse. I'm not hearing music. What? Okay. So the thing is, I always have music playing on the stream, specifically for you guys. And so let me try 20. And then some people were like, oh, it's too loud. So then I turn it down. And then everyone gets really mad at me. So how's that? Is that okay? So now the music is at -20. There's nothing. What? There should totally be something. Okay. Yeah, so I mean, like, I wouldn't be listening to music if it wasn't for stream, you know? Sound like someone playing music 2 buildings away. I mean, I can... Let's just go back here. I'll put it on -18 or something. So I put it at... It depends on the dynamic range of your speaker. So, okay, if I put it at 18... How's that? Is that better? We don't like music. We don't like music anyway? Well, I mean, if you guys don't like music anyway, then I don't know why I'm playing any. Like, I really only play it because of streaming. Like, I don't usually listen to it. But it's not at -18. It's like at -40. Wait, what do you mean it's at negative? Oh, probably because... Yeah, maybe. I mean, I believe it. Let me see. What do we have here? You should still be able to hear it. Let's see. Well, okay. The music is super low key. Like, it's not like particularly strong music. Okay. So I was surprised that you guys couldn't hear anything. I'm sorry about that. This should be slightly better. Okay. Thanks. Sorry about that. Cool. I watched my stream yesterday, and I swear it had music in the background. I can't hear it all unless I turn James up to headache-inducing volumes. Okay, maybe I'll... It doesn't matter. Like... Okay, well, let me put it at -15 then. And that's just where it will stay. You can go for the audiobook style where we put up our own music. I mean, I don't like streams without music. I don't know. I mean, I know Fret Chemist likes streams without music, but that's... I don't know. I tend to prefer them when they have some sort of music on. But yeah, streams shouldn't. Oh, no. Oh, gosh. Okay. I tend to prefer streams with music. That's me personally. I like the music. Okay. How about we leave it here, and then I'm gonna look at the stream afterwards, and I'll see how bad it is. We'll leave it here for a bit, and then when people get super annoyed at it, then we'll go from there. It's on the edge of distracting. No, I don't. The only reason I listen to music is for stream. So, like, okay, I'll turn it down to negative. See, this is 17. Okay, how's that? Okay, so it's -17. I'll leave it there. Not audible really still, but a notch up, and it would be too much. Okay, fine. We're not gonna talk about music anymore. I'm gonna leave it at leave it at whatever it was before, -15, and then that's it. That's what it's gonna be, -15. There we go. Okay, doing a manual descent algorithm on the volume slider. Let's see. You mean audible? Yeah, fair enough. Okay, so I'm actually super bummed that you guys couldn't hear the music. Anyway, that's fine. I don't care. It's fine. The random elephant. Hey, how are you? Okay. So what we're going to do is we are going to do draw frame plus 30, and then after each of these guys, we're going to add something to the draw frame. So we're going to do draw frame plus equals 1. Okay? So let's go here. We're going to run that visualization, /Sierpinski, and we're just going to see what happens. Right. So again, if you guys have problem. I don't know. We'll see how this goes. Now I'll never know if the La 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 song is playing. Wait, you surely can hear it now, right? Let's see. It's probably bad. No offense. You look like you'd blast the Backstreet Boys post 98. I don't know what that means. At all. I'm sorry about that. Oop. Because I've never seen what the Backstreet Boys are. Like, I don't know who they are. I mean, I know they played the song in Shrek. Oh, that's an interesting visualization. That is a super interesting visualization. What is going on? Huh. How young are you? I'm 27. Sorry. I don't listen to music. I literally don't listen to music, so I don't know anything. Sorry about that. Are you simulating the Triforce by any means? Kind of, in a way. Let's see. Were you homeschooled? No, I wasn't homeschooled. I just didn't listen to music. I genuinely don't like music. The only reason I'm okay with this music is because I've heard it so much, it's essentially white noise. So, yeah, music just isn't my thing. So, again, that was why I was kind of bummed about the music thing, because the only reason I'm listening to music is because of the stream. I wouldn't be listening to it otherwise. Let's see. Some people were productive instead of doing pop culture stuff. I mean, Fred Chemist is like, she's doing fine. I guess I stunted my growth to a teenager. I guess I stunted my growth to a teenage stage. It's depleting uranium and chemical science. Okay, here's that visualization again that we just had, just slightly faster. I think we need a few more frames to get the full Sierpinski triangle. Also, like, it is kind of a bit weird. Well, let's just let it play out. Let's see what happens. Like, because some of these, I think we need to let it play for a bit longer. What if we do... Okay, what if we change this to 5 frames? Okay, it's gonna be really bad looking, but we'll just let it go. Okay, let's see what happens. Let's see. I guess I kind of stunned my growth teenage stage. Triforce is the first iteration of the Sierpinski triangle. In a way, that's true. Okay. Let's keep letting this render for a second. It'll take like, I don't know how long it'll take. Triforce is the first iteration. Okay. So. Oh. MPV? What does this look like? Okay, it still looks kind of dumb. And it's still going a bit too slow, in my mind. But I just want to see if we can get to a full triangle state by doing this animation. No, it's hard to get to that triangle state. Let me increase the number of frames that we're running here to let's do 3,000. And let's just see what happens. G++ Sierpinski. It'll take a bit longer to render, and then we'll go from there. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. Yeah, we'll just see how this goes. I think this should allow us to render something that looks like the Sierpinski triangle. And then I just have to mess around with, you know, the size of each of these points to make it a bit more visible. You may wish to use... I hadn't seen the code yet. Sorry about that. I probably should have. Okay, let me get some water. Right. Wasn't Soding doing some like quantum information stuff the other day? I saw that and I thought it was really cool. I used to do some quantum information stuff a bit at the start of my PhD when I was learning it and stuff. But I didn't really do it as much as I kind of wish I could have, you know? It was always kind of on the list of things I really wanted to do more of. Nerdy wrote SDL2 graphing system. Looks nice. Right. Okay. So, I hope everyone's having a great day. Again, if you guys want to chat about anything, feel free to do so. This should be basically done in just a second, and then we can take a look at that visualization. But yeah, I think it looks kind of nice. I mean, like, it's a bit weird, but I think it looks nice, you know? Okay, cool. It's done. Let's take a look. MPV. So we should eventually see a triangle structure be generated here. I mean, you can see it is a triangle, right? But like, it should specifically start looking like the Sierpinski triangle, with more iterations. Maybe we just need to go through more children at once. Yeah, maybe we just have to do more at the same time. And that might be just what we have to do. Weird. Sorry, I'm just watching it. Can you draw lines between the dots? I can. But I'm not convinced that will... I gotta go. Still busy with uni. Are you streaming tomorrow? I should be streaming tomorrow at this time. I could draw lines between the dots, but I don't know if that's going to help too much with this visualization. So let me do draw frame. Okay. Oh, what? Draw frame. Yeah, there we are. Let's just do a DD here and paste there. Yeah, see what happens. G++ dash. Let's go. You can apply the inverse fast Fourier transform on it. I don't know how that's related to this. Anyway, Gathros, thanks so much for coming in. Have a wonderful day, and or wonderful evening, and I'll see you next time. I should be streaming here again tomorrow. Peace, man. Just to speed up rendering. Wait, how would an inverse fast Fourier transform at all speed up rendering here? Okay. Yeah, I don't think that's really relevant. Cool. But again, guys, if you have questions about like academia, anything like that, feel free to ask. And again, I'll do what I can to answer it. In some ways, this stream is, I don't know if I put the tag on for an AMA, but I mean, it's obviously open to anything. We're sitting here waiting for videos to render, right? So there's plenty of time to talk about, whatever you want to talk about. Could be GPU programming or something. I will usually be streaming. I think I'll have, since this visualization is pretty close to where I want it to be for the end of today, I think maybe we'll have 20 more minutes left at the end of stream. I thought I was supposed to have the middle empty. It does have the middle empty. Here, we'll watch it again. Yeah, we'll watch it one more time. Because I know if we draw it all at the same time, it looks like it is the Sierpinski triangle. The final form is the Sierpinski triangle. But all the intermediate forms might not be. So that's what I'm trying to figure out right now. Stepwise? Yeah, okay, I don't know. Give it a second to finish rendering, and then we'll take a look at it again. So, and again, if you guys have anything you want to talk about, feel free to do so, and I will do what I can to answer it. I mean, I guess as far as streaming stuff is concerned, it's not as much empty. It's not as much of it empty. I clipped it and it looked weird. Yeah, so it does look weird because of the way that we're doing here. So let's see. We're gonna do. It should be doing. It looks kind of the same, doesn't it? Oh, actually, you're right. That's not the Sierpinski triangle. Yeah. You're right. That's totally not the Sierpinski triangle. Why though? What are we rendering then? I swear we had the triangle before. Yeah, actually, I don't know what we're rendering then. You're totally right. It's like a middle stage between the two animations we saw before. Let me remove this animator. Draw frame. Let's see. Location, parent location, location. Let's remove these guys. Because I swear we had it before. Okay, so we'll just remove the number of frames also here to just like 100 or something to speed it up. Thanks for catching that. I mean, yeah. Jank Force is very far from a Triforce as well. Daslash Sierpinski. Let's take a look. Yeah, it doesn't take nearly as long. Okay, the points are not generated because of the fact that I didn't put them in the right location. Okay, let's see. So they're all at the parent's location, and we want to put them at the child location. Put it there, and then here we're just going to put it at location. And we'll change this again to 2, 2, where it was before. Okay. G++ dash slash blah, 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 and we'll let it run. And then, yeah, we'll just see where it goes. Again, guys, I've got maybe 15, 20 minutes left in stream. So if there's somebody that you want to raid at the end of stream, sorry about that. Feel free to let me know. Yeah, there's our triangle. That's definitely the Sierpinski triangle, no doubt. The final locations are definitely correct. Okay, so then, what Windows Manager? I'm using OpenBox is what I'm using. I'll type it in chat. Okay, so let's see. We know the final locations are correct because that's definitely the right Sierpinski triangle. Let's do 30 again. We'll do 30 again here. DD there and DD here. And let's see what happens. And I need to, let's just do D2D up here. Okay, let's try running that. G++. Actually, I think I need to increase the number of frames to, I don't know, 200 or something. 300 is just as good. Okay, G++. Dot slash Sierpinski. I have no idea. Maybe that's what you thought I said. That's fine. Okay. Shouldn't take too long to render, and then we'll just take a look at it. Right. Maybe it takes a bit longer to render than I thought, but, you know, we'll get there. Okay. Cool. Right. Final location is definitely the Sierpinski triangle. So then what on earth was I drawing before? Yeah, I don't know what was being drawn before, but clearly, you're right. That was not the Sierpinski triangle. So then, let's see. That's right. Modulo, it was somewhere between, right. Let's see, STD makes shared. I don't know, let's go back up here. I'm going to increase the number of frames to 3000. Again, and let's just go Hutchinson. Okay, and what are we going to do? If I increase this by 1, maybe that's a problem. Maybe we just have too many layers here. So let's change the level here to, let's just do 7. Let's see what this does. G++, dot slash Sierpinski. And let's just see how this goes. It'll probably turn out just as bad, but hey, I don't know. At least I'm trying, you know? Like, we'll get there one day. I don't know when that will be, but we'll get there one day. Yeah, I don't know what I was drawing though. It has to be something in between like the initial location and the final location. Otherwise it just doesn't, what I showed, I don't know. Boy, it's hot in this room. Oh gosh. But yeah, so we'll get this running and then we'll go from there. I'm hoping to have kind of this visualization done by, well, maybe the end of the day tomorrow or something like that, sometime during the week. I do have the script ready for the next video. We might go over that on stream sometime. But right, I'd like to get that video out next weekend. That's kind of what I'm shooting for that. So we have plenty of time to work on this animation and get it right. And I'm happy with that. I think it makes sense to spend some time, you know, getting this all done. Okay, so let's see what this looks like. Here we have, yeah, that looks right. Man, that's such a cool animation. Yeah, that's our Sierpinski triangle. Definitely. Although, I do think it's kind of weird. Some things about this are kind of weird, right? Like, oh, okay, never mind. There is a triangle in that. Is that it? Let me take a screenshot of this. What? Okay. GIMP screenshot. .png. There's something that does look a bit weird there. Let me scroll in really quick. Specifically, let's see. Let me change this to white. Oh, that's very big. Let's make that a bit smaller. Maybe that. Okay. So we have this triangle in here, right? There's our outer triangle, right? And this has to create an inner triangle here. I guess that's fair. I guess it does create that inner triangle. And that creates an inner triangle here. And also here. You know, so I think this works. It just looks funny in this interim stage. Let me increase. Discard changes. Let me increase the level to be 8 levels instead of 7 levels. And let's run that. G++ /Serapinski. Take a look at that visualization. And we'll see what it looks like. Then I'll just kind of play it. I like how the animation looks. It's really cool. It's just not... It's not quite what I wanted. So there's some other things that we have to do. But all the elements are there to make it what I want it to be. So, you know, we'll get there eventually. It's just some small scale updates to this visualization that we need to do. Right, let me get some water. Thanks, OP. Are you looking for the fastest vector calculus as an ellipse? No, not that I'm aware of. Okay, let's take a look at this clip. Let's see. I gotta go. Still busy with uni. I gotta go. Yeah, I have no idea what's going wrong with that animation. Wow, that's so weird. I gotta go. Still busy with uni. Huh. Well, okay. I'm gonna put this back here so I just remember to look at it later. Maybe the triangle just breaks temporarily due to the process. Yeah, I don't know. It's weird. I don't think I've ever seen it do something like that. So, play this, full screen that. So here's our 3 initial points, and then we just have, right, all the children being generated. Huh. Yeah, I like it. It's a nice animation. We might have a few too many frames. I'm trying to watch... there we have... Now we have the little kids being generated. Maybe we have just the right number of frames, actually. Yeah, that is a fun animation. I like that animation a lot. Oh, it should be finishing right on time, too. And it should be done right about now. Oh, no, we didn't have enough frames. How did we not have enough frames? That looks like it's a complete animation, doesn't it? Which ones are we missing? So this is, well, let's see. Keeps going for a bit longer. Interesting. Well, it's good enough. I'm happy enough with that. It looks like each point is stopping 1 step short of its final spot. Looks like 3 serpentine triangles overlaid on top of each other. Wait, what? Oh, could be. Yeah, I mean, that's fair enough. That is true. It is a few serpentine triangles overlaid on top of each other, definitely. And the reason for that is just because of the way that we're generating this. So we're taking point A, and then this is generating 3 children. 1, 2, 3. However, if we do P plus A over 2, where P is equal to A, the location will be the same. So then everything down this branch is going to be a copy of, like, does that make sense? Everything down this branch is going to be a copy of the branch before it. Does that make sense? So, let's see. Right, I think you're right, Funny Flywheel. I think we're just calculating too many points. So there's something we need to do with culling elements and stuff like that. But honestly, I'm gonna commit what we have right now because I think it's going okay. So you git add Sierpinski .cpp, and then we're gonna do git commit -m. Adding, let's see, simple animation for Hutchinson visualization. Visualization. I think that's right. Okay. And then git push origin master. So if you go to the Simuleos GitHub repo, you should be able to grab this animation. I'll let it play one more time, and then we'll I'll let it play a few times while we're finishing up today's stream and chatting a bit. And I'm also going to post it on Twitter afterwards. So, oop, hello. Let's see. What are you even talking about? Turning into what? Sometimes math gets you. Yeah, okay. Right, so this is the final animation we ended up with today. There's still lots of things to do before the upcoming video, but again, I'm relatively happy with how it looks. I think we're getting there. There's again a lot of stuff to do. I think I need to find a way to color code this so we know what's following what function. You know, because in the end, it just looks like a whole bunch of spaceships. You know, flying around the Sierpinski Triangle. I mean, I don't want to start any conspiracy theories on how pyramids were built, because they certainly were not built via mathematical simulation like this. But, you know, looking at the animation, I could see why some people might be, I don't know. I can see why people would be put off on this. So there's stuff to do, but I'm happy with it. I think it turned out pretty well. Okay, so let's go ahead and see who's live and who we want to raid at the end of stream. So let's see, we have Lana Lux who's live. Radical Fish Games, they are... Let's see, so they're working on Crosscode. It's actually a really good game. I'm a big fan. Kindred Dev, again, Game Dev, Das Valdez, NSF Live, Starship. So they're talking about, is that NSF or National Science Foundation? Interesting. CM Griffin, Anthony Writes Code. Who do you guys want to raid? Do you guys want to do more programming or more science, or what do you guys want to do? If you guys don't have any preference, I might do someone that we don't normally do. What's the NSF stream? I don't know. Let's take a look. Put a poll in the chat. Yeah, it could. Oh, that's not what I meant to click on. I meant to click on this guy. NSF stands for... is it National Science Foundation? SN4, Stack Complete, Virgin Orbit News. Yeah, so this is about NASA and stuff like that. You guys want to... I can create a poll really quick, but I think maybe that's too much. So... Right. What do you guys, so just poll of hands. You guys want to do more science, or do you guys want to do more programming? That's the question. First time commercial sector? Oh, cool. Yeah, we can do that if people are interested in that. But right, so I guess that's what we'll do. Okay. Thank you guys so much for coming in. Let's go ahead and start the raid on Das Valdez. Seems fine to me. So we'll do raid. What is that supposed to mean? The bleh? You don't want to do... Okay, who do you want to do, Folster? I don't mind. We can do anyone. I'm not particularly picky. But now you've made me second guess everything with that one emote. Thanks for stream. Yep. See ya. So again, if you guys have anyone you want to raid, let me know. Otherwise, I think I'll do Das Valdez. I think that's fine. We haven't been raiding science people so frequently lately, so I think it's probably pretty good to do. Okay, so let's go start that raid then. So raid Das Valdez. Right. Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. When I haven't decided what we're going to do exactly. Might be algorithm archive stuff, might be emotes, might be working more on the visualization. Lots of stuff to do, but I will be here tomorrow, maybe starting at a slightly earlier time. And I will see you guys next time. Bye, guys.